Hello student, in this class we are going to discuss the most important trigonometric identities proof based questions, because this one generally in your board paper it comes for 3 marker, but the students they feel difficulty solving this. So let us see the first. These 10 questions are from the past papers, previous year CBSE board paper. So let us start doing it. Here, how do we do it here? This is the first question. Now, what is given in the first question? Prove that here root 1 plus sine theta by 1 minus sine theta equals to sec theta plus tan theta. Whenever you get any identity based question, what you need to do here, first thing you have to take one of the sides. Generally, most of the time, left hand side, you will start with left hand side, you need to reach to right hand side. So let us start here with left hand side here. If I start with left hand side, what is given here? Square root of 1 plus sine theta by 1 minus sine theta. Now, if you will see the right hand side, there's no square root. So what I need to first do something so that the square root is gone. Now, you know that for the square root, I need the perfect square, because if it is in the perfect square form, then automatically square root can be removed. So what do I do to get the perfect square? You will see the denominator. Now, if it is in a, by most of the time, it will be in a plus b or a minus b form, right? So what I will do here, if it is a minus b, I'll multiply it with a plus b. If it is a plus b, the denominator, okay, you need to check only the denominator. If it is a plus b, you will multiply a minus b, because using this, I'm going to get the perfect square, right? This one. So what I need to multiply here? If I multiply, I need to multiply here 1 plus sine theta, because if you see in your denominator, you see a minus b, right? So this is what you are going to multiply here. First, put the bracket, because there are two terms, so it will be 1 minus sine theta, because if you are multiplying in the denominator, this will be 1 plus sine theta. If you are multiplying in the denominator, you have to multiply in the numerator also. So you will see, if it is in a minus b, I'm going to multiply a plus b, right? So what will happen here, if you will see now the numerator do not expand, because I need perfect square. So here, if you'll see, this is 1 plus sine theta, right? This is also 1 plus sine theta. So we will write down in the whole square form, because I need perfect square. So I have to do something so that my terms are in perfect square. And you know that it will become 1 square minus sine square theta. Right, so what are we going to get it here? Now you know the identity. What is the identity? You know, a minus a square minus b square. If you'll see in the denominator, 1 minus sine square theta is cos square theta, right? You need to mention this, or you can write down here, you know, the first identity, trigonometric identity, sine square theta plus cos square theta, it is 1, right? So I'm using that. So what will happen to my denominator? Denominator also will become a perfect square. So here, so we are going to get it cos square theta. Now numerator and denominator, they both are in the perfect square form. I can take it as one term here. And what are you going to get it? 1 plus sine theta by cos theta, right? So because see here, the square root is nothing but 1 by 2, it gets cancelled. So but right hand side, if you will see, I need term sec theta plus tan theta. So what I need to do here after this, I can separate the denominator here. So it will become 1 by cos theta plus sine theta by cos theta, right? And you know that 1 by cos theta is sec theta plus tan theta. So you are reaching here, using this, you are reaching to right hand side, and please write on the identity here. 1 by cos theta is sec theta, and by cos theta is tan theta. You reach to right hand side, therefore left hand side is equals to right hand side, hence proof. Now this is the next question of trigonometric identity proof. Here also, if you will see, this is also a square root based question. This is another question from past paper which has come. Now what you will do here, if you'll see here, there are two non-perfect squares. So you are going to repeat the same steps for both the square root, inside both the square root. So what do we do here? Let us start with left hand side here, which is 1 plus cos theta by 1 minus cos theta, right, plus under root 1 minus cos theta by 1 plus cos theta. Now the square root cannot be removed until unless it is a perfect square. So to make it perfect square, what do I need to multiply here? If you'll see, 1 plus cos theta by 1 minus cos theta. Now denominator is a minus b. So I'll multiply here a plus b to get the perfect square, right? So this is a plus b will be 1 plus cos theta. Here it will be 1 plus cos theta. Same thing you are going to repeat in the second square root also. 1 minus cos theta by 1 plus cos theta. Now your denominator is a plus b. That means you are going to multiply a minus b, which is 1 minus cos theta. So numerator also you multiply the same thing, right? Now here how do we do it after this? I need to get the perfect square. So numerator, please do not simplify. It will be 1 plus cos theta whole square. And denominator, if you use a square minus b square identity, what is a plus b times a minus b? It is a square minus b square. So whichever identity you are using, you need to mention that. So it will be 1 minus cos square theta. Same thing here. The numerator will be 1 minus cos theta whole square, and the denominator a square minus b square will become 1 minus cos square theta. Now numerator is already in the perfect square form, but denominator here it's not in perfect square form, so we are going to use identity sin square theta plus cos square theta. It is 1, right? So what I can do here, if in the numerator, denominator can be substituted 1 minus cos square theta. If I do 1 minus cos square theta, we are left with sin square theta. So denominator can be sin square theta plus here also 1 minus cos theta whole square, and your denominator will be sin square theta. Now if you see both the square roots, you are having perfect square in the numerator and denominator. So I can take it as a here perfect square. 1 plus cos theta whole square will become 1 plus cos theta by here sin theta plus 1 minus cos theta by sin theta, right? Now the denominators are same. I can take it as a common LCM, which is going to be sin theta. So this is your sin theta. So you will be left with 1 plus cos theta plus 1 minus cos theta, right? Now here the values are going to get cancelled, so it is 2 by sin theta. Now 2 by sin theta, look at your right hand side, you need to get cosec theta, right? So you know that 1 by sin theta is nothing but cosec theta. And the which identity we are using? 1 by sin theta. Cosec theta is the reciprocal of sin theta. So you have used this. Please write down the reasoning, which is nothing but equals to RHS. Therefore, LHS is equals to RHS, right? And hence proved. So in this way, these kind of square root based question, you should know that you need to first get the perfect square so that you can do the simplification. Now this is your question number 3. Here if you'll see left hand side and right hand side or left hand side, nothing is in the simplest form, right? So what are we going to do it here? We have to simplify left hand side, and then we have to simplify right hand side also. So let us start with left hand side. It is given 1 by cosec A. This is 1 by cosec A minus cot A. So let us take here cosec A minus cot A minus 1 by sin A, right? Then here what are we going to take it here, because we'll try to convert everything into sin and cos to get the simplest form. So it's going to be 1 by sin A minus cot A is cos A by sin A, right? And then minus 1 by sin A. Now you can see that the denominators are same, so I can write down as a common denominator. The LCM is going to be 1 by here, 1 by 1 minus cos A by sin A. Still it is there in the denominator, then you can take the reciprocal of the denominator. Now what will happen here, your sin A will go to the numerator, because here if I am having A by B divided by C by D, I take A by B into D by C. We can take the reciprocal of the denominator. So it will become sin A by 1 minus cos A, right, minus 1 by sin A. Now to get the common denominator, what do I need to do here? I can do the cross multiplication here. This will get multiplied here. This one will go there. So it is sin²A minus bracket 1 minus cos A by product of sin A times 1 minus cos A. Right? Now you know that if I have to open the bracket, so it will become sin²A minus 1 plus cos A, right, by, if I take it here, it is sin A times 1 minus cos A. Now how to do the further simplification here? You know that sin²A minus 1. What do I get it here? If I take these two terms, you know the identity is sin²θ plus cos²θ is 1. And I need here sin²θ minus 1, so it will become minus cos²θ. So in place of sin²A minus 1, I can write down here minus cos²A plus cos A, right, by sin A times 1 minus cos A. Correct? Now, how are we going to take it? Can I take here factorize? Take cos A common. So, it will become minus cos A plus 1. And denominator also, if you will see, if you want to rearrange so that you can cancel, I can write down as rearrange with the same sign here, right? 1 minus cos A can be written as minus cos A plus 1. Then this will get cancelled. You are left with cot A, right? Now this is because cos A by sin A is cot A. This is the simplification of left hand side. Now if you will see the right hand side, now right hand side you can't derive cot A into this. So what are we going to do it here? I have to do the simplification of right hand side also to get to check whether we are getting cot A, right? So let us take now our right hand side also RHS. This is your RHS. Okay, so what is this here? This is your RHS. Start with that. Again, you will repeat the same thing here. 1 by sin A is going to be as it is minus. Make sure you are using bracket if there are two terms. So 1 by sin A plus cos A by sin A, right? Again, the LCM, it's going to be sin A because the denominators are same in the second term. So sin A minus sin A will come in the numerator by bracket here. It is going to be 1 plus cos A, right? Now what will happen here? Again, I have to get the common denominator, which is going to be the product of denominators, which is sin A plus cos A, and you can do the cross multiplication here. So it will become 1 plus cos A minus sin²A, right? If you will see here, if I rearrange, cos A will be as it is plus 1 minus sin²A by sin A times 1 plus cos A. Now again, if you see this identity, 1 minus sin²A will become cos²A, right? So here, what are we getting here? Cos A plus cos²A. Now you can write down identity again if you want, because you are getting that value from the identity sin²θ plus cos²θ is equals to 1. I can rearrange as per my requirement. Now again take cos A as a common factor. So you are left with 1 plus cos A by sin A times 1 plus cos A, right? Now you can see that this common factor gets cancelled and you are left with cot A. Now you can see that left hand side and right hand side, both simplest form, you are getting cot A. That means that both the values are equal, right? So in some cases, most of the question you go from one side to other side, but in some questions you have to solve, you have to simplify both left hand side and right hand side. So they both are equal, to cot A, hence proved. So these kind of questions also you get. You need to decide if right hand side is not in the simplest form, you can solve RHS and LHS both. Let us go for the next question. Question number 4 here. What does it say here? It's given cos²θ by 1 minus tan theta plus sin²θ by 1 minus cot theta. We need to prove it. It is equals to 1 plus sin theta cos theta, right? Now here when we see the left hand side, if you see left hand side, The numerators are in sine and cos form. But here if you will see, the denominator is tan theta, cot theta. At the right hand side, everything is there in sine theta and cos theta form. So let us convert everything into sine theta and cos theta. So let us start with this question. It says here, first we will take here left hand side. What is there in left hand side? Cos² theta by 1 minus tan theta plus sin² theta by 1 minus cot theta. Now you know that tan theta and cot theta are reciprocal to each other, and tan theta is equals to sin theta by cos theta. Similarly, and cot theta is tan theta reciprocal, so I can write down cot theta as cos theta by sin theta, right? So what are we going to do it here? Substitute here, numerator remain as it is by 1 minus sin theta by cos theta in one bracket plus sin² theta by, what are we going to take here? If we take this, 1 minus cot theta will become here 1 minus cos theta by sin theta. Now you know that in the denominator you have to get the common denominator of both the terms. You will take it as LCM. For LCM you just do this cross multiplication, right? So here if I take this, this one will get multiplied with 1 and this will get multiplied with this. You can do this cross multiplication here. So what are we going to get it? Numerator remains as it is, right? In the denominator, you will write down cos theta minus sin theta by cos theta, right? Then here plus sin² theta as it is by sin theta minus cos theta by sin theta. Now you know that you have to take the reciprocal of these two because it's a denominator. So this one will go to the numerator, right? So how are we going to take it here? If I take this, if I take the reciprocal, what can we take it here? Sin cos theta will go to the numerator here, right? So if I take this to the numerator, it will become cos³ theta because cos² theta into cos theta, right? It will go to the numerator, this part, right? Similarly, this sin theta will get multiplied with sin² theta. So cos³ theta by cos theta minus sin theta plus sin³ theta by sin theta minus cos theta. Now, if you will see, you can see that we have to use here a cube, b cube identity, but the denominators are not in the same order. So first, let us keep it in the same order. It will become cos³ theta by cos theta minus sin theta, right? And here if I take minus sign outside from here, so this sin theta will become negative sin theta, cos theta will become positive cos theta. So what will happen here? Plus sin³ theta. So I can take negative common. So it can be written as cos theta minus sin theta. I have just changed the order. Now what will happen if I take these two signs, positive and negative, will become negative. So we will have here same denominators, common denominator. So cos³ theta minus sin³ theta, and the common denominator will become here cos theta minus sin theta. Now after this you have to use a cube minus b cube identity, a cube plus b cube, a cube minus b cube identity. It's very important in trigonometric identity proving part. So you have to write down here a minus b, a square plus b square plus ab. This is the identity that last year you have learned. So how will we do the simplification of numerator? Cos theta minus sin theta times cos² theta plus sin² theta minus negative will become here positive because here a plus ab, right? So here it's a sin theta cos theta by denominator is here cos theta minus sin theta. Now if you'll see here, it's in factorized form, so this factor will get cancelled with this, and this is one identity, sin square theta plus cos square theta, it is 1, right? So I will be left with 1 plus sin theta cos theta. Now this is nothing but your right hand side here. If you will see, we need to prove that 1 plus sin theta cos theta, and we got this 1 plus sin theta cos theta, which is equals to right hand side. Therefore we conclude left hand side. Here you have to use identity because you have used the identity sin square theta plus cos square theta is 1, right? So left hand side is equals to right hand side, hence proved. So again you have proved one more identity. You have to see that how are you going to reach to the right hand side. This is the next question here. What are they asking here? They have given that prove that if cos theta plus sin theta is root 2 cos theta. What do I need to prove here? Cos theta minus sin theta equals to root 2 sin theta. So we always start with here in these kind of question whatever is given. What is given? Cos theta plus sin theta equals to root 2 cos theta, right? Now how are we going to do it here? You know that I need square, then only I can use any of the identity. So what we can do here, squaring both sides. If I do squaring both sides, it will be whole square. This side also it will be whole square. Now this is in the form of a plus b whole square. So what is a plus b whole square? If I use the identity, you know that it is a square plus 2ab plus b square, or a square plus b square plus 2ab. So let us take it here, cos square theta plus sin square theta plus 2 sin theta cos theta equals to 2 cos square theta, right? Now here sin square theta plus cos square theta, it is 1, right? So this will be 1 plus 2 sin theta cos theta equals to 2 cos square theta, right? Which identity did we use here? Sin square theta plus cos square theta is equals to 1. After that, if I take here 2 sin theta cos theta is equals to 2 cos square theta minus 1. Till now we have to do something so that we get cos theta minus sin theta. Now here it's already cos square theta, right? So can I do here left hand side, let it be as it is. What can we do here? I'm going to substitute here in place of 1 sin square theta plus cos square theta. Why am I taking it here? Because we can see that here if we open it, if we are able to get a plus b, a minus b form here, we can factorize to get the answer. So it's a 2 cos square theta minus sin square theta minus cos square theta, which is nothing but is it cos square theta minus sin square theta, right? Now this can be written as left hand side, write on as it is. This side you have to write on 2 sin theta cos theta only, right? So here it's a 2 sin theta cos theta. Now what I'll do here, I can use here a square plus a square minus b square identity, right? Here what can we write on here? Cos theta plus sin theta times cos theta minus sin theta. Now if you see in your proving part, we need this value only, cos theta minus sin theta. So I'll try to transpose the other this value to left hand side. So it will become a denominator because it's a multiplier. It will become a divisor. So 2 sin theta cos theta by cos theta plus sin theta, and right hand side now we are left with cos theta minus sin theta. Now if I simplify this, I'll get the value of cos theta minus sin theta, which should be equals to root 2 sin theta. Now what is the value of sin theta plus cos theta? Root 2 cos theta. So substitute in this place, I can substitute root sin theta cos theta by root 2. Here how much we are getting it here? Root 2 cos theta, right? So I can take here root 2 cos theta, which is equals to cos theta minus sin theta. Now if you see here, common value will get cancelled. Cos theta with cos theta, and root 2 by 2 is root 2, right? So cos theta minus sin theta will be equals to root 2 sine theta, and that was the value we have to prove, right? So here, without taking left hand side, right hand side, we have done just the squaring both side, and we are reaching to this answer. So you can write down here, hence proof. Most of the trigonometry question, you take one of the side, you reach to here, but here by solving one equation, you are getting the result of the second one. Let us go for the next question. Now, in this question, next question, if you will see, this is again proving part. If you will see the right hand side, if I take the left hand side, it's a 2 cos square theta. So what I'll do in the left hand side, I'll convert everything into sine and cos, right? So let us start with, this is question number 6. We will take again left hand side, that is tan square A by tan square A minus 1 plus cosec square A by sec square A minus cosec square A, right? Everywhere there is a square. Can I use directly any of the identity? It's not possible. So what can I do? It's easy to convert everything into sine and cos, right? So I'll do here tan theta is sine theta by cos theta. So it will become here sine A by cos A whole square, right? So it can be written as sine square A by cos square A, because sine A by cos A whole square will be square of each of these trigonometric ratio. Here also we can write down here sine square A by cos square A minus 1, this is the numerator, plus cosec square A is 1 by sine square A, because cosec A is 1 by sine A, by sec A is 1 by cos A, so it's a cos square A minus 1 by sine square A. So whichever identity you have used here, what are the rules we know here? Tan theta is sine theta by cos theta you have used. Then you have used reciprocal. Cosec theta is reciprocal of sine theta, and sec theta is reciprocal of cos theta, right? So you can write down this. After that, let us find out the common denominator, so that we can reciprocate this, right? So what is going to be the common denominator? Numerator will remain as it is by cos square A. Denominator, if you do the simplification, this one will get multiplied here, right? So it's a sine square A minus cos square A by cos square A. Denominator will get cancelled also, but you can take the reciprocation, you can do, and then you can do the cancellation. Sine square A by, it is sine square A minus cos square A by sine square A times cos square A. What did we do here? Because the denominators were not same, so this gets multiplied here. Sine square A will get multiplied with the first numerator, and the denominator is going to be product of both the denominators, right? After that, what do we do here? We can take the reciprocation here of the denominator. So sine square A by cos square A times, here the denominator is going to be reciprocation, it's going to reciprocate sine square A minus cos square A plus 1 by sine square A, right? Now what is your denominator? Will become numerator, because you are taking you are reciprocating the denominator. This is also sine square A minus cos square A can be written in bracket, because it's a binomial term. There are two terms, right? Now what will happen, if you see here, this common values are going to get cancelled. One time this cos square A will get cancelled. So we are left with here sine square A by sine square A minus cos square A, then plus cos square A by sine square A minus cos square A. Right now the denominators are same. We can take it as a common denominator, because the denominators are same, so you can just add its numerator, right? And denominator is sine square A minus cos square A. Right? So here, if you know that sine square theta plus cos square theta is 1. So cos square theta, it is 1. So we can write down numerator as 1 by sine square A minus cos square A. Now we reach to this result, but if I see here, what do I need to get it here? if you see the right hand side we don't have sine term. You see 1 minus 2 cos²A, right? And we know that sin²A can be written in terms of cos. How will we write on here? It can be written, this term sin²A can be written as 1 minus cos²θ minus cos²A. See, using this sin²A, you have to transpose cos²θ to right hand side. Now here, if you write down, it is 1 minus cos²A minus cos²A. They both are negative. You are going to add 2 cos²A. Now you reach to here right hand side. 1 by 1 minus 2 cos²A. You can see here we wanted this result and we reached to right hand side. So we can write down here, therefore left hand side you have shown it that it's equals to right hand side, hence proved. So this is the way again we are using which identity in this question, sin²θ plus cos²θ is 1. This is our next question. So what is given here? Left hand side the terms are given in tan, cot. Right hand side if you'll see it's given in the form of sec, cosec, sin, cos, right? So first let us see in the left hand side I can use one of the identity, right? First use identity and then later on we can convert everything into sine and cos form. See, there are different ways to do it. It's up to you what do you do, but try to follow the easier way, right? I can use here a cube plus b cube identity, but if you see here the denominators are not same. So let us first see that if I take here left hand side, it's a tan cube A by 1 plus tan square A plus cot cube A by 1 plus cot square A. Right, so first let us start using the identity. What is the identity I can use here? It is tan cube A, 1 plus tan square theta, it is sec square theta. So I can write down here sec square A plus cot cube A by 1 plus cot square theta is cosec²A, right? So which two identities did we use here? 1 plus tan square theta. You can convert everything into sine and cos also and you can do it, right? So here 1 plus tan square theta is going to be sec square theta. I can take here theta. It can be any angle, right? So it is tan square theta, right? And if I take here tan square theta and if I'm taking 1 plus cot square theta, we can take it as cosec square theta. So this identity we are using. Now after this step, you can convert everything into sine and cos. So tan cube theta will become sine cube A by cos cube A. This is the numerator. Then denominator is cos sec theta is reciprocal of cos, so cos square A. Right? This is the denominator. Plus cos cube A by sine cube A. This is the numerator. And what is the denominator? 1 by sine square A, because cosec is the reciprocal of sine, right? So now because it's dividing the fractional value, I can take the reciprocation sine cube A by cos cube A. This one will go to the numerator cos square A by 1 plus cos cube A by sine cube A times, if you reciprocate 1 by sine square theta, it will become sine square A by 1. Right now, if you will see, you can cancel cos square A and it will become cos A. Here sine square A and sine cube will become sine A. So we are left with sine cube A by cos A plus cos cube A by sine A, right? Now look at here, the right hand side, if you will see, there is no denominator, right? It is just given sec A, cosec A plus 2A sine A. So first thing, what do I need to do here? I have to get the common denominator. Well, how will I get the common denominator? I can do here cross multiplication. So this one will become sine to the power 4a, because sine cube A into sine A will be sine to the power 4a, plus cos A into cos cube A will be cos to the power 4a by sine A cos A. Now to get this term, the right hand side part, if you see, it's what you are going to get it here, sec A cosec A minus cosecA, we have to get here cosecA minus 2 sin A cos A, right? So if you will see here sin A cos A. Now, once you see here, you know that the denominator 1 by sin A cos A will become cosec A sin A, but the one of the term should be 1, and the another one, if you'll see, it is 2ab term, right? So what can I do here? Because I need a plus b whole square, and this is a perfect square. Can I write down as whole square plus cos square a whole square? Now to get a plus b whole square form, I'll add here sin square a, because this is your a, right? Sin square a is your a term. This is, if this is a square, this is b square, then 2ab term is going to be 2 sin square A cos square A. Now this is the extra thing I have added. So the same value I have to subtract. Now these kind of terms you have to see that what is right hand side, which result do you need it. Based on that you are going to decide. Now first three terms will become, this is 2ab, a plus b whole square, because I am using identity a plus b whole square. What is your value of a? Sin square a plus cos square a. Why am I taking a plus b whole square? Because I know sin square theta plus cos square theta is 1 minus, now which term is left? 2 sin square A cos square A by sin A cos A, right? Sin A, not sin square A. This is sin A and cos A. Now after that, what do? Sin A cos A. You know that here the identity sin square theta plus cos square theta is always 1. So by numerator, one of the term will become 1. Can you see here? 1 square is going to be 1 minus 2 sin square A cos square A. Now in the right hand side there was no denominator. So what I'll do after this, I'll separate its denominator, because this denominator belongs to both the terms. So can I write down this as 1 by sin A cos A minus 2 sin square A cos square A by sin A cos A, right? Here if you will see, this is nothing but 1 into 1, right? Now after this, 1 by sin A is cosec A, 1 by cos A is sec A, right? So after, what can we write down here after this? It is cosec A sec A. Now here you can cancel also this, so you are left with the right hand side result. Now you can see that here, what did we need here? Right hand side, sec A cosec A minus 2 sin A cos A, and we reach to that result. Please rearrange as per the given question. It's because it's multiplication, you can change the order also. Minus 2 sin A cos A, which is nothing but you reach to right hand side, and left hand side is equals to right hand side. So your identity is proved here. So this is our next question, question number 8. It's given here sin A plus cos A by sin A minus cos A, plus you are having the reciprocal of it is equals to 2 by 2 sin square minus A. Again you can see that left hand side, you can start with left hand side, and you will see that you will check how are we going to reach to the right hand side. So take here, left hand side is sin A plus cos A by sin A minus cos A plus sin A minus cos A by sin A plus cos A. Now if you will see, right hand side is also sin. That means to do the simplification, first I have to get the common denominator. How to get the common denominator? Here do cross multiplication and take the product of the denominators, right? So here also this one, because there are two terms, put it in the bracket. So if sin A plus cos A multiplied with the first numerator, it will become sin A plus cos A, because it's the same value, it will be whole square, plus same thing, sin A minus cos A gets multiplied with the second numerator, it will become whole square minus cos A whole square, and then you take the product of the denominators. Now product is in the form of a plus b times a minus b, and a plus b times a minus b, it will become a square minus b square. So your denominator, if you'll see, it is a minus b, a plus b. So what are you going to get it here? In the denominator, a square. So it will become sin square a minus cos²A. Now look at here, your denominator is not having here any cos term. So you can change your cos square theta as 1 minus sin square theta. So first simplify the numerator. A plus b whole square will be a square plus b square plus 2ab. 2ab will be 2 sin theta cos theta, right? So here I can write down 2 sin A cos A in one bracket, and then plus sign here also sin square A plus cos square A, minus 2ab will be 2 sin A cos A, right? You have used the identity a plus b whole square, a minus b whole square. Now in the denominator there is no cos, so sin square a will remain as it is. In place of cos square a, I can write down 1 minus sin square a. Which identity again we use here? Sin square theta plus cos square theta is 1. Correct? Now do the simplification. In the numerator also you can use this identity. The first two terms will become 1 plus 2 sin A cos A. Now there is no minus sign, there is a plus sign. So no change in the second bracket values, right? So this also will become 1. Here this also has become 1 using the identity. So this one with the same sign, because in the middle there is a positive sign, minus 2 sin A cos A, and open the bracket in the denominator, it is sin square A minus 1 plus sin square A, right? Now look at the numerator, what will happen? This term gets cancelled. So we are left with 2 by, then here what will happen? Sin square A plus sin square A will be 2 sin square A minus 1. Now look at here your right hand side, 2 by 2 sin square A by minus 1, right? So you have reached to right hand side. Therefore, left hand side is equals to right hand side. You started with left hand side, reached to right hand side. Hence proved. This is your next trigonometric identity proving based question. Now this question, it's combination right hand side, it's given you have to use sec square theta equals to 1 plus tan square theta. The similar type of question is there where you'll have the combination of cosec square theta and cot square theta, and you need to use the identity cosec square theta equals to 1 plus cot square theta. So let us start here. Again, you can see that I have to use the identity. That means we cannot have the terms with sin theta and cos theta. So what is there in your left hand side? It's given in terms of sin theta minus cos theta plus 1 by sin theta plus cos theta. It's given here, it's not a, it has to be theta. So this is change it to theta, then minus a, because either minus 1, whether it will be given angle as a or theta, right? So what are we going to do it here? You need sec theta and tan theta. So you should know that means sin theta, if it is divided by cos theta, you get tan theta, right? Similarly, when 1 is divided by cos theta, you get sec theta because it's a reciprocal of cos, right? So what will I do here? Because numerator and denominator divide by cos theta. Both your numerator and denominator, you need to divide by cos theta. If it's cosec and sec, you will divide by sin theta, right? So each term will be divisible by, each term you have to divide by cos theta. So sin theta minus cos theta plus 1. So this is your numerator, divide by cos theta. This term also divide by cos theta, because all the terms denominator is going to be same, cos theta. Then because you are dividing in the numerator, same thing you have to repeat in the denominator also. So cos theta plus cos theta by cos theta minus 1 by cos theta. right? After that, what do we do here? If we see, now you change your sin by cos is nothing but tan theta minus 1 plus 1 by cos is sec theta by tan theta plus 1 minus sec theta. So you can see that all the terms are now in second tan form. Now after this, because we have to use identity, and identity is always in square form. So what is the identity? Sec square theta is equals to 1 plus tan square theta. Now I can't use identity for here first term and third term, right? So where I'm going to use here, see for this one we can't use identity because it is not in whole square form. So what can I do here? Wherever it's written 1, in place of 1 I can write down sec square theta minus tan square theta, right? So how will we do? You have to rearrange. So I can do it here, sec theta plus tan theta, because they both are positive, put it in one bracket, minus 1, in place of 1 you are putting here sec square theta minus tan square theta. Why did I write down sec theta plus tan theta instead of tan theta plus sec theta? Because you will see that a plus b, a minus b will be in the form of sec theta then tan theta, right? And denominator, you don't substitute here any identity in the denominator. Denominator, write down as it is, 1 minus sec theta plus tan theta. Right? Now here in the numerator, first term remains as it is, first bracket plus tan theta, right? In the second one, again I can use a square minus b square identity. For this place I can use here a square minus b square identity. So this is sec theta plus tan theta times sec theta minus tan theta, right? It is a square minus b square by 1 minus sec theta plus tan theta as it is. Now what you need to do it, because in the right hand side you don't see any denominator, right? There is denominator, but there is 1 in the numerator. So what I'll do here, you can see if I do the factorization, sec theta plus tan theta is here, sec theta plus tan theta is there in the second term also. So take that common, sec theta plus tan theta is the common factor. What will be left in the first term? This term, it will be left 1 minus as it is. And what is left here? Sec theta minus tan theta. Right? And denominator write down as it is, 1 minus sec theta plus tan theta. Now here after this, what are we going to get it here? Sec theta plus tan theta. And here if you see 1 minus sec theta plus tan theta. I am using distributive property to open the bracket here. If I take it, sign will change because it's when you open the bracket, negative sign is there. Then by 1 minus sec theta plus tan theta. You see that the denominators are same and it is in factorized form. So this will get cancelled with this, right? So you are left with sec theta plus tan theta. But what is my proving part? It is 1 by sec theta minus tan theta. I am getting numerator sec theta plus tan theta. So to get the same denominator, I need sec theta minus tan theta in the denominator in the right hand side. So what can I do here? That value is not there. So what I can do here, I can multiply the same value to numerator and then in the denominator. It's not going to change the actual value, right? So what will happen to the numerator now? It is in a plus b, a minus b whole square form. So it will become sec square theta minus tan square theta by sec theta minus tan theta. Now you know that sec square theta minus tan square theta is 1. Minus tan square theta is 1. So my numerator has become here 1 and here sec theta minus tan theta. So you reach to right hand side. You started with left hand side. So you need to keep seeing what do you need in the right hand side, left hand side. Based on that, you multiply or divide by the same value, right? So here hence proof. This question is done. Let us go for the next question. Now this is your next question. Let us see how we are going to do it here. This is given here. Prove that left hand side equals to 1, right? So how are we going to start here? Start with left hand side, which is given as sine to the power 4 theta plus cos to the power 4 theta by 1 minus 2 sine square theta cos square theta. Right now, the moment you see sine to the power 4 theta, you know that you remember the identity sine square theta plus cos square theta is 1. So we have to do something so that we are getting in this form sine square theta and cos square theta. So what can we do here? Can I write down this as sine square theta whole square plus cos square theta whole square. Now we can have a plus b whole square, right? So what is there in a plus b whole square identity? We are having a square plus b square plus 2ab. So you are already in the numerator, you are having a square. This is your a, so this is a square. This is your b, this is b square. But we don't have 2ab term. So what can I add? I can add plus 2ab and I can subtract 2ab. This is not going to change my actual value. So what we will do, we are going to add 2 sine square theta cos square theta and we will subtract the same value so that we are not changing the actual expression. Now denominator write down as it is sine square theta cos square theta. Now the first three terms, if you will see, this is nothing but in the form of a plus b whole square, right? Then a plus b whole square is a square plus b square plus 2ab is a plus b whole square. So sine square theta plus cos square theta whole square, and the last term will be as it is minus 2 sine square theta cos square theta. Then write down denominator as it is. What is there in the denominator? 1 minus 2 sine square theta cos square theta. Now the first bracket, because sine square theta plus cos square theta is 1. 1 square is also 1 minus 2 sine square theta cos square theta by 1 minus 2 sine square theta cos square theta. Now numerator and denominator are same values, right? So you can just cancel both the values. So how are you going to cancel it here? This will get cancelled with this whole and you will be left with 1 time because you are cancelling. So this is 1, which is nothing but equals to right hand side. So now this is left hand side. So what was the most important part here? You have to remember what needs to be added and subtracted the same value to get a plus b whole square form. Hence proof. Hope you all got these questions. So keep doing practice so that you will be clear with these kind of trigonometric identities based questions.
Thank you for watching this video. Please like, share and subscribe. Also, keep practicing.